Is it safe to take iron if you have SIBO? Stay tuned if you want to find out. As with anything else having to do with our health or human physiology, this is really complicated, and I'm going to do my best to try to answer this concisely and precisely for you, because I know you just want to know the answer to that question. Is it safe for me to take iron if I have SIBO? And I think that the answer is, for most of you, yes, but there's a few people who might want to be a little bit cautious, and I'll tell you about why that is. But let's talk about the physiology and the anatomy of what's happening here, and then we're going to go into it in more detail. Now, the reason why you would want to take iron is pretty straightforward. If you're iron deficient, or if you have anemia, you're tired, you're lethargic, you have brain fog, nothing feels like it's working, you could take iron and feel a heck of a lot better if you treat that iron deficiency. But the way that that impacts your gut healing journey is going to be maybe surprising to some of you. So here's my horrifying laid out version of the human GI system. For those of you who are new, you might not have seen this before, but the idea is that food comes in through the mouth, goes through the short tube, the esophagus. We've got the stomach, the big holding sac here. We've got the nice long small intestine or small bowel, and then we have the colon, aka large intestine. And normally, for people who don't have SIBO, the way this should work out is that you should have a colon that is chock full, filled to the brim with lots and lots of bacteria, yeast, viruses, maybe some parasites. We're still learning about it, but you should have lots of creepy crawlies, lots of critters in your colon. And then there should be a smattering, you probably can't even see those dots, a smattering of bacteria along the rest of the GI tract. So it's normal to have some bacteria in your esophagus, your stomach, your small bowel. The problem with SIBO, small intestinal bacterial overgrowth, is that the quantity, the number of bacteria goes up. So that's really the crux of why the condition has that name. So we have more bacteria filling up part of the small bowel. It could be down low, it could be up high, could be smack dab in the middle. And the flora, or the bacteria and the yeast and the critters that live in that area where there's an overgrowth, tend to start resembling that of the colon microbiome rather than the small bowel. I have a video on this channel somewhere, God knows where now, but I have a video from the last year or so where I talk about how stool testing cannot and never will be able to diagnose SIBO, because the stuff that exits your rectum is going to look completely different than the critters who lived higher up in the system. So the ratio of the bacteria and the types of bacteria that you're pooping out in that stool test are not at all reflective of what's living in the small bowel. I will try to remember to link that in the description somewhere, but I'm probably going to forget, just saying. So going back to this though, so you have an increased quantity of bacteria. The hesitancy for using iron when you have SIBO, and what I see perpetuated a lot in the Facebook groups and even some scholarly resources like blogs, is that the idea is that some bacteria can use iron to form what's called a biofilm. And if they are gobbling up your iron before you get a chance to absorb it, or if you're just giving them so much iron that you have a surplus of it, then you're going to strengthen their biofilms, and that could make it harder to get rid of the infection. And just to rewind for like a quick sec, I'm going to just give you a little quick mini 2-second tutorial. So if you imagine, here are the cells of your intestines. Let's say it's the small bowel. If you have an infection, let's say we have a bacteria, which I'm actually going to draw in red, so it's a little clearer. Let's say there's a bacteria and a bacteria, bacteria, bacteria. If we came in with something like oregano or neem or rifaximin or some sort of antimicrobial or antibiotic, it would be really easy for that chemical to just target these bacteria that are out free floating and they have no protection. A biofilm, I like to refer to it as the slime dome, and it's like a shield. It's like a fortress or a slime dome that's protecting the bacteria. So then when there are antimicrobials or antibiotics used, the idea is those drugs or those compounds will only really affect the bacteria that are outside the biofilm. These guys can survive, and they can go on to propagate the colony, and they can survive despite the antibiotics. So that's the concern with SIBO, is you don't want your bacteria to become resistant to your efforts of killing them. You want to be able to wipe out the SIBO, get rid of the dysbiotic state, the overgrowth, and move on with your dang life. So the thought of the bacteria outsmarting you and evading your antimicrobial regimen is really, really scary and really disheartening to somebody who has SIBO. Now, here's the thing that I don't see talked about nearly as much, and it should be, this should get a lot more airtime. So again, we talked about the GI system from mouth to anus, and hopefully a lot of you who have subscribed to this channel for a while or listened to my podcast or been around the block with SIBO, hopefully a lot of you are understanding now that in addition to focusing on the gut, which is totally worthwhile and necessary, we also need to think of other body parts and how they influence the gut. And namely, I want to focus your attention on the nervous system. So I tried to do a cross-section of your brain. Good enough. Your nervous system is really, really, really super duper important for regulating your gut and its function. So for example, the vagus nerve, that famous nerve that we're all talking about, and it's all over the internet, there are vagus nerve resets, vagus nerve supplements, vagus nerve essential oils, vagus nerve, exercises, and people are humming and gargling. People are gargling, trying to stimulate this nerve. And the reason is it's really important. So the vagus nerve comes out of the brainstem, slightly inaccurate here, but deal with that. And it goes down to your stomach and it tells your stomach to make HCl, stomach acid. That's really important for killing the microbes as they come in so that you don't reinfect yourself. It's really important for digesting your food, especially things like protein, iron, and B vitamins. It's really, really important for regulating motility. And stomach acid itself is important for triggering the reflex that causes the gallbladder and the pancreas to release their juices. And as an added bonus, we have that the vagus nerve also goes down and stimulates your pancreas, which look something like that. And then now you get more pancreatic enzymes. The vagus nerve also comes over here. That's a really funky looking branch. And it turns down inflammation and it regulates the function of your liver. It also goes to the gallbladder and it tells the gallbladder to release bile into the intestines. And we all know that bile is a natural antimicrobial compound, so that's a pretty big deal. The vagus nerve also has branches that regulate the enteric nervous system and the motility apparatus in your gut. So it literally keeps the food and the bacteria moving through your system from mouth to anus the way that it should be. The vagus nerve is going and innervating sphincters, telling them when to open and close. That includes the sphincter at the top of the stomach that prevents acid reflux. If it starts to malfunction, the lower esophageal sphincter gets too loosey-goosey, you start to get reflux. The vagus nerve seems to innervate that. The sphincter that controls stomach emptying, that also is under vagal nerve control. The sphincter that closes off the small bowel and the colon appears to be under vagal nerve control. So you can get this sense that the vagus nerve in particular regulates everything in your digestive system. Your ability to digest your food, your ability to absorb your food, your ability to move the food and the bacteria and the contents of your bowel from mouth to anus at a reasonable pace, an appropriate pace. That's motility, and that's the thing that you need to cure SIBO. Well, here's the thing, going back to the topic for today's actual video. No part of your body works well when it's deprived of iron and when it's deprived especially of oxygen. If your iron deficiency gets so bad that you start compromising your ability to make hemoglobin and red blood cells and you actually become anemic, that's super, super serious. But you also need enough iron to make thyroid hormone. You need enough iron and enough oxygen delivery to the stomach to make HCl. This is a very energy intensive process and it's very, very inflammatory in nature, and your parietal cells need a boatload of oxygen and they need iron constantly bringing them the oxygen so that they can do their job. Well, no body part works when it's inflamed, and no body part works well when it's deprived of oxygen. Particularly though, that is most true of the nervous system. And that's probably why a lot of the symptoms of iron deficiency, a lot of the symptoms of anemia have to do with cognition, right? People will get really, really lethargic and worn down. They feel like they need to sleep all the time. They might be a bit depressed. They're brain foggy. They feel like their brain doesn't work. Like nothing feels like it's working in their body. And a lot of that is nervous system based because your brain starts to become starved of energy. Well, if your nervous system is starved of energy, how efficient do you think your vagus nerve is going to be? I'll give you the answer. It's not going to be efficient at all. It's not going to work. So we have all of these people marching around right now who have IBS or SIBO or both, and they're deficient in iron, or maybe some of them are even anemic, and their vagus nerve doesn't work. But here they are trying to obliterate things with antimicrobials and talking about biofilm disruptors and talking about these strategies to try to annihilate the bacteria. But even once you clear the SIBO, if you're not using your motility, if you're not clearing the bacteria out of the small bowel, the problem just comes back. And I think that also, for that matter, this kind of gives the illusion of being a biofilm problem, right? Like if you had a real biofilm problem, I'm going to do some videos on biofilms, probably over the summer, by the way, guys. If you want to see those a little sooner rather than later, motivate me and comment down below, because I've been putting it off for like a year. And I'm starting to wonder if I'm going to get off my butt and do the biofilm series that I've been thinking of. So if you want biofilm videos sooner, motivate me and put a comment down below, because I've been putting that off. But if you think about a biofilm, the behavior of a biofilm-based issue would be you take the antibiotic, you feel pretty good, you go off the antibiotic, and the symptoms start to creep back in. You take the exact same antibiotic. So like say the people who take rifaximin over and over again, you take the antibiotic again, you feel good again. You go off and the symptoms come back. You go on it a third time. The same antibiotic works for a third time. And then you get worse. And you have this cycle where the same exact strategy, the same exact antibiotic keeps working. But when you go off of it, the symptoms come back. That's very indicative of a biofilm type problem. But if you think about it, in SIBO specifically, that's also really indicative of a motility problem. If you treat the SIBO and you kill off everything in the gut, and you feel pretty good doing that, you cleared the bacteria, you lowered their number, and you feel okay, but then it creeps back in, that could also be that your motility never recovered to a point that it was able to keep the bacteria out and brush them down to the colon. So you get rid of them for a little while. It takes maybe a couple days or a couple weeks or a couple months for the bacteria to build back up because your motility sucks. I say that with love. And then you're right back to square one. So it can be hard to differentiate the two of these. I think much more commonly in the world of SIBO, it's really a motility problem at its core rather than a biofilm issue. But again, I'm going to do some videos about that in the near future. So this is the reason why and I know my podcast co-host Amy, really press the issue of, please, for the love of God, get on iron. Now, in the second half of this video, I'm going to talk about the microbial part of it. Because like I said, me telling you that you need iron and the motility piece might not be entirely convincing, and I get that. We're going to talk a little bit about where does the evidence actually point to us as far as the bacterial biofilm kind of stuff, and is that something you need to be concerned about? Or do you have free reign to treat the iron, treat the deficiency, get your iron levels back up and enhance your motility without any ill consequence? Okay, welcome back. I wanted to be able to show you my screen for part 2 of this video. So we're going to do a little bit of poking around on PubMed, and I'm going to show you why people are so concerned about taking iron, or even really scared to do so. So we can see here I went ahead and I put this into PubMed, iron biofilm Pseudomonas. And you can see we got a whole bunch of hits, 362 on this day. The thing to know is that the vast majority, maybe even all of these articles, are on plastic or glass or some sort of material that could be inserted into the human body. That's where the bulk of biofilm research really is going, and where it's coming from. It's when they have to put in a catheter or a PICC line or a mesh or a metal screw. They want to know if the bacteria are going to form biofilms on that material and if it's going to lead to an infection in the people who need those implants. A lot of this research is not explicitly focused on the GI microbiome. And even when it is, it's still a petri dish based study. They take out the bacteria out of the person or out of the animal, they put on a petri dish, and then they watch and see what happens, and they mess with the bacteria a bit. But that being said, just pointing out some of the flaws in this and how it's not going to be directly translatable to human physiology and human situations, what I can show you is that Pseudomonas in particular, there seems to be a lot of research on. So this is where I was saying most of you can probably take iron without ill consequence. Some of you maybe could be a bit hesitant. So, for example, we could see Pseudomonas overgrown on stool tests, so indicating a colon overgrowth of Pseudomonas. We could see that on tests like the GI map. I worked with a gentleman this year who had 10,000 times the amount of Pseudomonas as the top end of the GI map range. Now, I don't really trust that company for a lot. I think that their ranges are a bit skewed and they're not really measuring what they say they are. But when I see something like that, I'm concerned. I want to treat something that's 10,000 times higher than it should be. So he would be a good example. When you see a Pseudomonas overgrown that outrageously, probably don't give that person iron. Or if you are that person, don't take iron for a while until you get the Pseudomonas under control, just to be better safe than sorry. But you can see interdependence between iron acquisition and biofilm formation in Pseudomonas aeruginosa, iron uptake and biofilm formation, iron metabolism in Pseudomonas aeruginosa biofilm. You can see there's a lot of different articles, and it does suggest that Pseudomonas might enjoy gobbling up some extra iron. Now, for those of you who have SIBO, remember, stool testing does not diagnose SIBO, and it does not indicate what type of SIBO you have or what is overgrown in your small bowel. We cannot deduce that from stool testing. Pseudomonas is sometimes associated with SIBO when they suck the juice out and they culture what's in there. Much more frequently, though, it looks like it's going to be Klebsiella and E. coli. Those seem to be the two biggest players in SIBO, and Pseudomonas is like maybe number 3, 4, 5, 6, somewhere in that range. So it's a little bit further down on the totem pole, per Dr. Pimentel's research at least. So let's look for Klebsiella. Much fewer results. Now, this might be because Pseudomonas is a much more common infection in people with inserts and catheters and meshes, so there's not as much research going toward Klebsiella perhaps. But you can see there's a couple of articles. It's not quite the damning amount of evidence as we saw with Pseudomonas, but there is some evidence, meaning that maybe there's some hesitancy with folks with SIBO, perhaps. I think that this is less compelling to be sure. And again, this is going to be mostly looking at individual infections, so like this with a liver abscess, or in the case of something like a catheter or something that's implanted into the body. But I wanted to pull up a couple of individual articles as well. So here's, this is just one of the many articles about the iron acquisition helping with biofilm formation in Pseudomonas aeruginosa, and they give some pictures even. So this one seemed like it was a little bit more focused on GI stuff, so you could see like a picture of the epithelial cells. But this one I found really interesting. So remember what I said, E. coli is the other bacteria that overgrows in SIBO most frequently. Actually, I think it's even more common than Klebsiella, if I remember correctly. But look at the title of this one. Uropathogenic, so this would be in the urinary tract. It's a little different, but we're going to go with it. Uropathogenic E. coli forms biofilm aggregates under iron restriction that disperses upon supply of iron. So it might be the opposite for E. coli. It might be that E. coli forms a biofilm more effectively when it's deprived of iron, and when you supply iron again, it actually breaks up the biofilm. That's the complete and total opposite of what the SIBO world would have you believe. Now again, this is uropathogenic E. coli, so it's going to be a little different, and it is, as I said, it is it's essentially a petri dish study, so we can't really take this directly and apply it to human beings, but it is very curious. And it's the same level of data that we're looking at when we look at all those articles about Klebsiella and Pseudomonas for that matter. Now, here's where things get really spicy. You ready for this? Let's look at Bifido, one of our favorites, which, as a side note, is deficient in practically everybody in the developed world, as far as I can tell. If you have SIBO, there's probably a 99% chance you're deficient in bifidobacteria. And as a side note, do not believe the GI map for this. They're dirty, rotten liars, and they are not good at assessing bifido. That's a topic for another day. So let's look at this. So this is 2001. Suppressive effects of bifidobacteria on lipid peroxidation in the colonic mucosa of iron overloaded mice. So this is one thing that we've known, is that too much iron can be toxic and inflammatory to the human body. Most of you will never ever have to worry about that, but for some people who have really, really high ferritin, really high serum iron, high red blood cells, they might have a condition called hemochromatosis, And it's a genetic condition that means that they just absorb iron like a freaking champion. And for those people who deal with iron overload, it looks like bifidobacteria can suppress the oxidation or the inflammation in the colon in mice who are experiencing iron overload. Really interesting. So lipid peroxidation, that's one flavor of assessing inflammation. Just know that. Moving on. 2015, a little bit more recent. Bifidobacteria strains isolated from stools of iron-deficient infants can effectively sequester iron. And what they said in this study, somewhere down here I think, the vast majority of the strains of bifidobacteria that they looked at are able to sequester iron. Now what gets really weird and interesting here, if you look down here to their conclusion, the ability of bifidobacteria to effectively utilize iron sequestration methods may confer an ecological advantage and be the basis for enhanced competition against enteropathogens. So now does this mean that the iron is somehow feeding bifidobacteria and enhancing their survival and their growth? Or the bifidobacteria gobble up the iron and then they make something that inhibits pathogens? Or is it literally that the bifidobacteria are stealing the iron from the pathogens? Either way, it might not matter a whole heck of a lot to you guys, because at the end of the day, this means as long as you have some bifidobacteria, you can get away with taking the iron, and it's going to, the bifido are going to suck up the iron before it ever gets to the pathogens, like E. coli and Klebsiella. So maybe we don't need to worry as long as we're being mindful of our good bacteria. And as a side note, what is one thing that has repeatedly been shown to suppress bifidobacteria? The low FODMAP diet. What do we have all the SIBO people doing to try to beat their SIBO? Avoiding iron and restricting FODMAP consumption. I think we're missing the boat, guys. But there's a few more. Okay. 2016. High iron sequestering bifidobacteria inhibit enteropathogen growth and adhesion to intestinal epithelial cells in vitro. So again, Petri dish type study. In vitro means in the lab, in vivo means in the body or in a living thing. So it's another kind of Petri dish level article, but the bifidobacteria that are able to sequester iron inhibit the growth of bad bacteria. How freaking cool is that? Like, problem solved. You guys, you can take iron. You can take iron until it squirts out your ears. Well, maybe not. That would be really bad. But you can take iron. Just make sure that you're feeding and taking care of your bifidobacteria. The worst case scenario is probably somebody who is deficient in bifido. They're taking lots of antibiotics and lots of antimicrobials, which is so common in the SIBO world. They take a whole bunch of iron, or maybe they avoid taking iron for long enough that their motility sucks, and they've got these pathogens. I mean, the mind reels, but I continue because there's one more. 2020. Regulation of hepcidin iron signaling pathway interactions by commensal bifidobacteria plays an important role in the inhibition of meta-inflammation related biomarkers. So this is another one sort of similar to the first one with the lipid peroxidation. But if you look here, let's see, results. Bifidobacteria inhibited LPS and oleate-induced protein expression of inflammatory cytokines concomitantly with decreases in cellular Tg and iron concentration. So the thing to know, these cytokines, TNF-alpha and IL-6, those are inflammatory signaling molecules that the immune system uses to communicate with itself. So when there's an infection or tissue damage or something bad happening in the body and you need an immune response, those chemicals tell the immune cells, hey, I need help over here, come over here and help and take care of this pathogen or take care of this inflammatory thing that I don't want to deal with. And when they go up, IL-6 and TNF-alpha, it makes you feel really inflamed. So you'll feel tired and brain foggy and achy. You'll have joint aches and pains, muscle aches and pains. Your brain feels like it doesn't work. Basically all of the flu-like symptoms can be attributed to one or both of these inflammatory cytokines. the bifidobacteria inhibit their expression when LPS and this other compound, oleanate, is released. Or oleate, sorry, mispronounced that. So what are we doing fearing the iron? We have these bifidobacteria that are more than capable of scarfing up iron if there is indeed a genuine excess when it gets down to the microbiome. They could scarf up the iron for you and either protect you from inflammation or protect you from the microbial consequences of that, the biofilm disruption or the biofilm formation effects of this. So please, 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 unless you have a really wicked bad Pseudomonas overgrowth, like what I described with that gentleman with his GI map that was 10,000-fold higher, please take iron if you're deficient. I really, really strongly think that it will help with your motility and your brain function and your energy levels, and that's going to help with your SIBO journey. By the way, did anybody notice that I picked a rust-colored shirt for the iron video? I amuse myself to no end, but it's the little details that really make these videos extra special. Hey guys, if you like this video, be sure to subscribe, ring the bell, click the like button, and leave a comment down below with the videos that you would like to see me do next. Doing all of those really helps support the channel and support my efforts in making as many videos as possible for you guys. Thanks so much, and I'll see you in the next video.